We're going to continue with Unit 5, and now we're getting into the math portion of Unit 5. So, this, a lot of students think, oh gosh, I just can't, oh, I don't want math, I'm so math phobic. Don't worry, this is a great review of Units 1 and 2. So we've been talking about solutions, and something that comes up with solutions is how to express concentration. And so what I mean by concentration is if you have two people and one person likes a mild tea and the other person likes a really strong tea, how can you quantify the teas that they like? Well, a way to get around this is to use concentration. And there are many different ways to express concentration. We're going to go over percents first, and then we're going to talk about molarity. So percentages, it's a fraction times 100, and it can be very useful. So the first percentage that we're going to talk about is mass percent. And that is grams of solute over grams of solution. And then you multiply that by 100. Notice that since you have grams over grams, your units will cancel out. And so when you calculate a mass percent, your units will just be in percent. Now mass percentage is commonly abbreviated M/M percent. So if you see MM percent, that means mass percent. Older textbooks and terminology use weight percent. It's the same. It's still grams of solute over grams of solution. Now, let's revisit what a solution is made up of. So if you have a solution or mixture, what comprises this? Well, recall that it's made up of solute, which is the smaller amount, or the component that changes phase, and then you have the solvent, which is the larger amount and most often doesn't change phase. For our purposes, unless it's otherwise specified, the solvent is water in Unit 5. Okay, the next percentage that we're going to talk about is volume percent. And this is milliliters of solute over milliliters of solution times 100. Now, you're not limited to milliliters as your volume. You could have liters of solute over liters of solution, and that would still be volume percent. Most frequently, we will see milliliters used for volume percent. Just like with mass percent, your units cancel out, and you're just left with a percentage. Abbreviation, a common abbreviation for volume percent is V over V percent. The last percent concentration that we're going to talk about is mass volume percent. So it's kind of the two previous percent concentrations combined. So you have the grams of solute over milliliters of solution times 100, and that gives you a percent. You could write gram/milliliter percent if you'd like to, if you're really particular about your units, which is not a bad thing to be. The abbreviation for mass volume percent, M over V percent or W over V percent. So, if you were given information, enough information, you could calculate the percent concentration. Let's say you have 362 grams of salt and this is made up of 1 liter. Let me write 1.0 liter solution. Based on the percent concentrations that we've learned, we have enough information to calculate mass volume percent. So, in order to calculate mass volume percent, we would put 362 grams of salt, that's our solute, over, we'd have to convert 1 liter to milliliters, so it would be 1.0 times 10 to the third milliliters. Now you might wonder why I put that in scientific notation. I did that to show that we only have 2 sig figs in this number, while in this number we have 3 sig figs. And you guys are probably saying at this point, sig figs? I thought we were done with sig figs. But remember, sig figs are always, always, always present in chemistry. So, when we divide this out, we're going to have 362 divided by 1,000. I'll put that in parentheses. So 1,000 times 100. So 362 divided by 1,000 times 100 gives me an answer of 36.2. You can put grams per milliliter percent. Careful with your sig figs. We need to have 2 sig figs. So the mass volume percentage would be 36%. So I gave you a specific problem. Now, that's one way you could be asked a question about percent concentrations. Another way is to calculate the amount of solute. So let's say I have a 4.5% volume per volume beer. And I have, let's say 125 milliliters of this beer. So, in this case, my solution is the beer. And I want to know how much solute. So the solute would be the ethanol. So how much ethanol is in 125 milliliters of beer? The concentration is 4.5% volume per volume beer. Now with these problems, it's very important that you keep track of your units. So you're going to look at this color. This is your starting quantity. This is your conversion factor. So that's conversion factor. So I'm going to set this up. 125 milliliters of beer over 1. Now, this is where units come into play. This is also where understanding percentages come into play. To account for the percentage, we're just going to say that we have 100 milliliters of beer. So take it out of 100. So if you know that you have 100 milliliters, how much of the milliliters is alcohol based on the percent that's given? 4.5. So, and we'll talk about this more and more when we go over a lot of practice problems. So 100 milliliters of beer, and then 4.5% of that is alcohol or ethanol. So notice how I've set up my conversion factor. I've set it up so that milliliters of beer cancels out. So this cancels out, this cancels out. Also, now I'm left with milliliters of alcohol. Now notice, if I didn't label alcohol and beer, you could have flipped this conversion factor and gotten milliliters to cancel out. So you need to be very careful with that. So to work my math, so I've already taken care of the 100 by assuming that we have a 100 milliliter sample of beer for the percentage. So 125 divided by 100 times 4.5 gives me 5.625 milliliters of alcohol. I need to have, let's see, I have 3 sig figs here, 3 sig figs here, so my answer should have no more than 3 sig figs, so 5.63 milliliters of alcohol. Alright, so that's one where you're asked to calculate the solute. What if you're asked to calculate the amount of solution? So let's say that we have 5.5% mass per mass sugar solution, and I have 2.6 grams of sugar. How much sugar solution can I make up? Well, this is your starting quantity, 2.6 grams of sugar. This is your conversion factor, 5.5% mass per mass. So you have 2.6 grams of sugar. Remember that your percentages, it's always grams of solute over grams of solution. So our solute in this case is sugar. So I can write 5.5% two ways as a conversion factor. I'm going to get out another sheet of paper. Okay, so we have 5.5% mass per mass sugar solution. Can write it out two ways. I'm always going to take these out of 100, so I can have 5.5 grams of sugar over 100 grams of solution, or I can flip it and have 100 grams of solution over 5.5 grams of sugar. So I'm going to pick whichever one gets my units to cancel out with my starting quantity. And if we flip back, we need the grams of sugar to be on the bottom. So we're going to use this conversion factor. So I'll have 5.5 grams of sugar on the bottom, 100 grams of solution on top. So grams of sugar cancels out, leaving me with grams of solution. So 2.6 divided by 5.5 times 100. I end up with 47.27 repeating grams of solution. And I wrote my units out. That probably got cut off. Check my sig figs. 2 sig figs. 2 sig figs. So my answer can't have more than 2 sig figs. So it's 47 grams of solution. So I've given you every scenario that you will come across when dealing with these percent concentrations. Things to keep in mind when working these problems. Sig figs, probably the #1 mistake when working these problems. The other commonly made error is flipping units, not keeping track of whether you're dealing with solute or solution. So make sure that you're very, very anal when writing out your conversion factors. So I want you to hit pause and work on problems 1 through 5. So keep in mind what we've talked about and double check what the question is asking before you dive into just plugging numbers in. So hit pause and work on questions 1 through 5. Okay, so the first problem, you're asked to calculate the mass percent. So you're going to put the mass of the solute over the mass of solution, multiply by 100. So 5.25 grams sugar over 22.43 grams of solution times 100. 3 sig figs gives you 23.4%. Okay. Number 2, you're asked for how much ethanol is in a 125 milliliter glass of beer. The beer concentration is 3.2% volume per volume ethanol. This is your conversion factor. This is your starting quantity. So put 125 milliliters of beer over 1, 3.20 milliliters of ethanol over 100 milliliters of beer. For sig fig purposes, we don't take into consideration the 100, so you don't have to worry about that. Milliliters of beer cancels out. We're left with milliliters of ethanol. So you have 3 sig figs, so 4.00 milliliters of ethanol. Okay, number 3, it's asking for how much solution can you make. This is your conversion factor. This is your starting quantity. So I'm going to put 34.01 grams of sugar over 1. And then to use this conversion factor properly, 7 grams of sugar, 100 grams of solution. Grams of sugar cancels out. 34 times 100 divided by 7 gives you 485.85 grams of solution, but I can only have 3 sig figs, so 486 grams of sugar solution. Okay, number 4, 75 milliliters is my starting quantity. 5% is my conversion factor. So I will put 75 milliliters. Now I have to be careful in labeling this. 75 milliliters. Is that solution or solute? So be very careful when reading these types of questions. How many milliliters of methyl alcohol are needed to prepare 75 milliliters of solution? So it's solution. Your solute is right here. So that's your solute. So you're given 775 milliliters of solution, and it's 5% volume per volume. So 5 milliliters of methyl alcohol. You guys could draw that out if you wanted to, because you know the structure of methyl alcohol. over 100 milliliters of solution. This cancels, and you get 3.75 milliliters of methyl alcohol. Two sig figs. So it's 3.8 mils of methyl alcohol. Okay, and the last question, how many grams of solute are needed to prepare the following solutions? So they're asking for grams of solute. These are my conversion factors. These are my starting quantities. So A, 100 milliliters solution over 1. It's W over V, so that's mass over volume. So it'd be 12 grams glucose over 100 mils of solution. That cancels. So it'd just be 12 grams of glucose. Now be careful, because starting quantity only has 1 sig fig, right? So it would be 10 grams of glucose. All right, B. Start off with 75 milliliters of solution over 1, and then 2 grams of KCl over 100 milliliters of solution. You end up with 1.5 grams of KCl. And that's got the correct number of sig figs. So with these percent concentration problems, be very careful on sig figs. Also be very careful on labeling your units. It's very easy to flip things around if you don't label your units properly. Okay, so we'll stop here for this lecture. The next lecture will cover another type of concentration that's not a percent concentration, but it will be mixed in with all the percent concentration questions. So be familiar with percent concentrations. Work on your homework problems. The lab that you can do the lab on concentration. So I believe that is lab 20, 19 or 20. But you can start working on those because it deals with mass, volume, volume, percent concentrations. And molarity is asked in those labs. That will be covered in the next lecture. So until next time.